thing that happens outside of the Earth's atmosphere. It's going to be so fun, and maybe some of us will want to be aerospace engineers and astronauts after this class. I don't know. Maybe I will want to change my career path after this class. Anyway, I'd like to hand over to Clarissa because she's going to be introducing the class for us. So over to you, Clarissa.
Yeah, hi, thanks, Victory. So usually Kenneth joins you today, but my name is Clarissa, and I'm taking over again. I saw you guys yesterday. Well, hi everyone. After a couple reminders, after today's workshop, we will be taking a 2-week break. So no workshops, but we will resume on August the 1st. So don't worry, there's a lot of exciting things coming. On the first Saturday of August, we are starting a new session, and this time it'll be focused on FLL and EV3 robotics software simulation, hosted by FTC Team Second Rebellion. So stay tuned for that. And in the future, don't worry, we have even more things in store, like FTC programming, maybe prepared by more FTC teams. And topics will get increasingly difficult, and I'll get more focused into electricals and more programming. And you guys don't know what we have in store, so keep on being excited and learning from all of this. Along with these topic focused workshops, Code Orange will the FRC team will release several FLL and EV3 programming workshops and sessions, and we'll release more information when we have more information at hand. And just a reminder, there is no CAD sessions this week, but there is a CAD video available for you guys to keep on practicing. So I hope you guys are honing your skills on your own, and yeah, keep on being fired up all about STEM. And yeah, this is just a great opportunity. And with that, I will be introducing our presenters today. So again, our presenters today are Boeing interns from Huntington Beach, California. And they're joining us from many different high schools with many different backgrounds. So I hope today they can provide you a great insight about space and all the things they've learned over this past summer. So the first presenter we'll have is named Presley from Diamond Bar High School, and he's also the mechanical lead of Team Sprocket, which I hope you guys have seen twice before presenting for Coderina. And then the other presenters we'll have, well, we actually have two Davids. We have David T and David B. Oh no, I might mix this up. One David is from Westminster High School, and one David is from Tustin High School, but I forgot to put the last names. From Westminster High School, can you just... Okay, and from Tustin High School, can you... Okay, so I'm assuming you guys got it. But yeah, be pumped up today, guys. This workshop will be on space debris, satellites, and the environment. So it's not just something we can focus on Earth, but we're, like Victory said, we're expanding to zero gravity going out there. So yeah, good luck, presenters, and I hope you guys learn a lot from this.
Okay, everyone. So hello again. My name is David Bui, and yeah, can't wait to start. So we're going to start off with space debris and how there's just so many things to account for in terms of the pros and cons, or actually just the cons of space debris in general. So now we're going to move on to space environment, and there are many things that are accounted for in space, and one of them is gravity. And there's going to be a lot more that I'm going to mention in the future, but as of now, we're just going to focus on gravity. So you might be wondering what gravity is, and if you already know, that's awesome. But for those who don't know, gravity is a force that pretty much opposes against two objects. So let's say between you and the Earth, if you were to jump, it would pull you down, so you wouldn't be flying as you were jumping. This is, however, very different if you were to go to another planet or a moon. So if you were to go to the moon that orbits around Earth, if you were to jump on it, the gravity would actually be less. So you'd actually be able to pretty much fly, not fly, but you'd be able to at least jump for a while. And so same thing applies for Earth in terms of how things orbit. And so just like the moon, which we consider as a satellite, there are other things like the International Space Station, which is also a satellite that orbits around Earth due to the gravitational force between those two objects. And so since Earth has a bigger mass, it pretty much is able to pull anything to it. So the moon or anything by any chance that's orbiting it is attracted to Earth. And so another thing to account for in space environment is the atmosphere. And so shortly in this presentation, we're going to be mentioning the use of the atmosphere and how effective it is. But as you can clearly see on the diagram on your far left, there are a lot of spheres to account for. And so just with that being said, most things or most activities that human activity is located in is the troposphere. So this is where you primarily see commercial airlines or airplanes. And so this is where most air pressure is pretty much in. And in terms of thermosphere, that's the highest sphere you're probably going to get to. And there's absolutely no air pressure. So it's a lot more smoother if you were to go up. So let's say you were to have a commercial plane and compare it hypothetically to the troposphere and the thermosphere. The troposphere would probably have some air turbulence, and that's why you would see it's not as smooth as the thermosphere because there's actually no air and pressure at all. So if you were to fly in the thermosphere, it would be a very smooth ride. However, that isn't possible with the technology we have right now. So right now we're only at the troposphere level. So now I'm going to mention about vacuum. And in space, there's a vacuum space. So what happens here is that there's little to no pressure at all. And so with that being said, it's a state of matter where there's absolutely no matter that has, where its pressure is like low in particles in space. So it doesn't affect any processes that are carried on. So with that being said, if our bodies were to be in space, in vacuum space, our bodies wouldn't be able to survive because of the lack of adequate pressure. So for instance, if an astronaut were to step outside without their spacesuit, they would automatically explode. It has the same effect, just like how if you were to dive into the ocean, but this time it's without all that pressure that's pulling you down. It's the pressure that's kind of making you squeeze in instead of squeeze out. So actually, the same thing applies. But if you were to go down the ocean, you'd pretty much blow up too because of the immense pressure. But just like in space, it's the same thing that applies. You'd practically explode. And I'm going to show you a demonstration, a video of how internally, that's how we would feel if we were in space. Okay, so it seems like the audio is not working, but clearly, as you see, he's giving a demonstration, and he's about to begin the process of putting two marshmallows in a vacuum chamber. So he just put a happy one and a sad one, just by chance. And right away, once you see the vacuum chamber turned on, you're gonna see that it automatically just shifts in, and it just like how our bodies would work, the cells in our body would just shrink, and it wouldn't be able to live at all. And so same thing applies to our marshmallow. So we would pretty much expand until poof, we would explode. And we also have another, in space, the environment that we have is also accounts for radiation. So radiation is not a thing that you can just smile upon, though there are some pros and cons. There are mainly cons in it. So radiation in space comes from the sun and is generally blocked by Earth's atmosphere. So we're thankful that we have those types of spheres that are able to withstand the radiation, because if not, the UV sun rays that were to be casted upon us would affect us drastically, and we probably would not be able to survive. So the pretty much this allows us to not be exposed to radiation through the Earth's atmosphere layers. But if you were to go up to each sphere, so referring back to the diagram that I showed you previously, if you were to go to let's say past the troposphere and you go all the way to the exosphere, the amount of radiation you would actually get is a lot more. And so you wouldn't probably want to be up in space, because the amount of radiation you would be exposed to would be very harmful for you. And so I'm going to list out the different types of rays that you would pretty much see that is in terms of radiation. So the first ray we have is UV rays, which are harmful for your skin. So this is why you really want to go out with sunscreen or any type of lotion that can protect your skin. And now we have X-rays. X-rays have a higher frequency wavelength, which is used in the medical field, so that's why we call it X-ray. And we have gamma rays, where like a short type of wavelength, which can damage the living cells. And so you don't want to mess with any type of these waves or these rays that are radioactive for you. And then lastly, we have thermal rays, which can cause heat when we go outside in the morning and we step outside, we would feel kind of a type of heat on our skin. And so that's the type of thermal ray that we're feeling. And this can be ultimately powered for solar panels and even outside objects in space.
So now we'll go into how orbits work around the Earth. So when a satellite is launched into space, there are three main factors that you need to meet in order to achieve orbit over the Earth. So the first one is that the velocity of the object needs to be over 17,000 kilometers a second and at least 242 kilometers away from the Earth's surface. Second, the object must be able to balance itself and not lose its trajectory, or it could get thrown back into the Earth or get thrown further into space. And the third factor is that you need to continuously maintain that distance, because if the satellite is too close or too far, then it can either get pulled in or it'll keep moving away from where you want it to be. So LEO, which stands for LowEarth Orbit, is the closest orbiting ring around Earth at around 2,000 kilometers away or closer. So many satellites are in low Earth orbit, like the International Space Station, because it's the fastest type of orbit to go around the Earth. And it's also the safest in terms of exposure to other aspects of the space environment. MEO, which stands for Middle Earth Orbit, is the second closest orbiting ring around Earth, and it's between 2,000 and 36,000 kilometers above the surface of the Earth. It's also mostly used for satellites using GPS, as the altitude and the orbital pattern gives it the perfect view to see the Earth. And GEO, which stands for Geosynchronous Orbit, is the farthest orbiting ring around the Earth, which is about 36,000 kilometers and more above the surface of the Earth. So most of these satellites are used for communications, weather tracking, and other things like cable TV. Since these satellites don't require any tracking, these satellites are extremely useful for receiving information. So you may be wondering, how come we don't have to track these satellites? The reason is because these satellites, they move at the same speed as the Earth's rotational period. So basically, this means if you're looking at one of those satellites from Earth, that satellite would always be in view, because as the Earth rotates, the satellite is moving at the same speed, so it'll always be in view. Also, you might have also heard about geostationary orbit, and the difference between geostationary and geosynchronous orbit is that geostationary orbit is on the same plane as the equator, but geosynchronous orbit is on a different plane. And now we'll get into the specifics of satellites. So what is a satellite? Well, Google defines a satellite as any object that orbits a planet, moon, or star. But when we think of satellite, we usually think of some kind of machine orbiting the Earth. So what do satellites do? There are thousands of satellites that orbit the Earth, and satellites do many different things, like take pictures, provide a GPS location, but most of these are used for communication, such as TV and cell phone signals. So the Global Positioning System, or GPS, it's made of more than 20 satellites that orbit the Earth, and these satellites are all used in tandem to figure out a person's exact location around the globe. And these satellites are used by millions to billions of people every day. So why are satellites important? So satellites are important for many different reasons. First, they have a bird's eye view of the Earth, and they can see large areas of the planet at one time. So this allows them to collect data about the Earth much faster than instruments on the ground. And satellites can also see into space much better than telescopes, as they're above the clouds, dust, and molecules in the atmosphere that block our view when we look from down here. So we'll go over the main parts of a satellite. So there's 4 main parts. There's a power system, a way to control its altitude, an antenna for communication, and a payload. So the power system can be either a solar panel or a battery, which I know you all learned about a week or 2 ago. The antenna sends and receives information, usually to Earth, and the payload collects information. So how do satellites orbit the Earth? So satellites are usually launched into space using rockets, and then it has to achieve those 3 factors I named earlier. It has to move at least 17,000 kilometers per second, stay around at least 242 kilometers away from the Earth's surface, and yeah. So geostationary and polar orbiting satellites, those 2 are the most common orbits for satellites. Geostationary satellites usually travel from west to east over the equator, and polar orbiting satellites travel from north to south, going from one pole to the other. And now we'll go over satellite crashes. So satellite crashes are quite rare because when a satellite is launched, it's designed so it doesn't crash into other satellites or larger pieces of debris. However, orbits, the path that a satellite may take may change over time, and as that path changes, the likelihood of a satellite crashing into other satellites, larger pieces of debris, or the small undetectable pieces of debris increase.
So now we're going to go to the main idea of this presentation, which is space debris. And so the basic idea of space debris is that it's anything that's non-functional. So it can range from an inactive satellite that is no longer useful for any particular reason, or it could just be anything that came off from a rocket throughout its stages. So it could be a screw that fell off during the process of a rocket launch, or it can even be a speck of paint that was perhaps, entering or going out of Earth's atmosphere. Next slide. So how does space debris end up in space? And just like I previously mentioned, it's mainly due to the exponential increase of how we want to improve on space exploration. So because of all these diverse countries, like, all these countries ranging from the United States all the way to Russia, they have been competing against each other. And I'm going to talk about this in the next slide. However, that's something I want to bring up. Most space debris is caused through the launch of rockets. And so once a rocket is launched into space, the main purpose is to bring either transportation, cargo into a space station, or maybe to launch a satellite up in Earth's orbit. And so now to answer the question of space debris, it primarily ends up in space because, one, it's considered as trash, and it's very hard to get in terms of the technology we have right now. But that's something that we're working on in order to prevent it and mitigate the amount of debris. So just like I previously mentioned, space debris became a major problem back in the 80s. So once, I'm going to talk about this soon after this slide as well. Donald Kessler, who worked for NASA, mentioned to NASA and warned them that there was, space debris is something that is that should not be considered as not a big deal, whereas it should be a big deal. And so during the Cold War, in the late 1950s, this is where it really started. Two nations, Russia and the United States, were highly competitive in terms of who was going to be the best. And so because of all of these tests and trial and errors, when they were to launch a rocket, they were successful and unsuccessful times. And just with the mix of both, a lot of those test rockets, or if not those rockets that he launched, were pretty much, if they were to end up in space, there would be no way to retrieve it. So it would just end up, either in low Earth orbit, or if not in a different orbit, perhaps middle Earth orbit. And so what would happen here is that there would just be a collection of debris that's just orbiting around Earth. And so throughout the late 1950s all the way to now, we can see that there's an exponential increase of debris that should be mitigated, or else it will get worse in the future. And so what do I mean by it will get worse in the future? If you look at this image right here, those are the impacts of just how a speck of paint can cause. And so if you think about a massive satellite that's inactive, colliding with another satellite will be a catastrophic event, and you don't want that. And even though that might be rare, most collisions deal with little particles or any debris that's orbiting around Earth, and it could hit the space station, and it has. And so just like on this image on the right, here's an astronaut that pretty much has to perform some maintenance on the space station because of debris that might have hit it. And so these kind of situations put a lot of astronauts in jeopardy because it could, risk their life, and it actually does. So that's something to account for. And so now I'm going to move on to Kessler Syndrome. So I can't wait to tell you guys about this. He is a scientist from NASA, and he actually was able to warn NASA in 1978 about how space debris would be a cascading effect. And so what I mean by cascading effect is, you can see in a diagram on the very top right, you can see that it exponentially increases over the year. So if you look at the graph on the very far right, it pretty much is a graph explaining to you of what the image is depicting. And so ultimately, Donald Kessler was able to warn NASA that this is not a deal or a matter that should be taken not seriously. It should be. It should be taken seriously. And so all the debris and all the things that you have to account for must be mitigated in the future, or else pretty much Earth in the future will be covered even more, as you can see. And so now we're going to rotate over to collisions that have actually happened in space. And so as Presley previously mentioned, It is rare, but it has actually happened. And there are real life scenario events that actually happened back in 2009. So the satellite Cosmos 2251, which was from Russia, and Iridium 33 from the United States actually collided with one another back in 2009. And this caused thousands of debris to pretty much orbit around, to be collected in low Earth orbit. And another event that caused more debris to rotate in low Earth orbit was when China launched the anti-satellite missile, which destroyed their inactive satellite. But without knowing, they were pretty much adding more debris onto Earth's orbit. And so this primarily affected a lot of devices, perhaps satellites, in low Earth orbit as well. So a great example would be the ISS, the International Space Station per se. And so the International Space Station has been hit multiple times, and it's only going to increase if we don't stop, mitigating the amount of debris that's already orbiting around Earth. So here's a video that depicts a great example of how catastrophic pretty much a debris hitting another active or inactive satellites. Whichever both, it's not good because it's going to add more debris and it's bound to hit something in the future. So the ultimate goal of this presentation is to pretty much warn you guys that there is no good in terms of space debris, and that's something that we have to account for. Just like global warming here on Earth, we don't really know it until we really see it. So why not prevent it now when we have the time instead of waiting until it gets a lot worse, to the point where we have to take and spend a lot of money in order to really clean this up. So starting now would be a great time. And so in terms of starting now, there's actually two rules that we can perform in space, in terms of what we launch and in terms of what we do in the deployment of those devices, perhaps a satellite or a rocket. So the first thing that we want to do is prevent. And this can work in prior development in terms of building a satellite or a rocket that can mitigate the amount of debris that it can contribute. So by adding solar cells, which is pretty much something that allows it to take it to somewhere else in far distances throughout space, this will allow it to perhaps maybe after the active satellite is no longer active, after 30 years of service, it will pretty much move out, and through the use of solar cells, it can bring it to the other rule, which is the removal method. So it can bring it back to an orbital graveyard or perhaps an atmosphere, Earth's atmosphere, so it can lead to a fiery death. However, we can even use ion fans in prior development and attach it to satellites. That way, it can also do the same task as a solar cell and bring it back once it knows that it's no longer useful or functional. So it can bring it back to Earth's atmosphere for a fiery death, or again, or orbital graveyards where it won't affect us in the future. However, if all that does not work out well, and it seems that we can't use solar cells or ion propulsion engines, we're probably going to have to retrieve it remotely. And so we're probably going to have to use different types of removal methods or things that can capture orbital debris, because there's a vast field of how debris is like. It's not always going to be set still where you can easily grab it. Sometimes you're probably going to have to slow it down because it's rotating at an incredible speed that's super violent for any satellite to catch or any device. So there are some methods, and out of our research, we believe that using nets and claws are the great ways in terms of capturing debris. So maybe using ion fans in prior development can stop the violent rotation or the speed of the satellite or debris. And this can allow us to use furthermore of like the nets or the claws to pretty much capture it and then ultimately remove it in the end.
So why is space debris so dangerous? Why are we trying to get rid of it? Next slide. Although space debris may be unseen by the eye, their impact is immeasurable and very impactful on space equipment like solar panels, satellites, and space shuttle orbiter windows, as shown by the image above. According to one source, in low Earth orbit, with an average impact velocity of 21,600 miles per hour, even tiny particles can wreak havoc on spacecraft. NASA often had to replace Space Shuttle orbiter windows because they were significantly damaged by these minuscule pieces of space debris. A professional working in the aerospace industry posted a picture of an experiment done with a light gas gun, which generates very high velocities similar to that of a traveling piece of space debris on a block of solid aluminum. It should be noted that although this looks enormous, the crater is about 5 inches deep. Having said that, the crater was caused by something about the size and weight of an eraser on the end of a pencil. The photo above shows Russia's Mir space station, seen here in 1997, and which incurred damage after a collision with the resupply ship. This collision scattered thousands of pieces of space debris across Earth's atmosphere. This, like any other space debris, indirectly threatens the ISS and any other satellite, which is about the size of a football field, making it an easy target for space debris. To solve this, it has to move its orbit to make sure it doesn't get battered by debris. Every once in a while, however, the ISS incurs damage from pieces the size of a paint chip and requires repair for weeks. Easily the most dangerous aspect of space debris besides its fast-traveling nature is its unpredictability and ability to stay unseen by radars and the human eye. Although debris smaller than 1 millimeter in size does not generally pose a hazard to spacecraft, it can still damage optics and solar arrays. So while a spacecraft may survive being hit by tiny debris, larger hits can still result in catastrophe and mission failure. The amount of space debris in space has only increased over the past 60 years and is predicted to continue doing so if a solution isn't applied in the near future. In fact, NASA has set guidelines for what precautions to take while in orbit for many of their missions. Many predict that if this persists, space debris will form a kind of blockade around the Earth, which means humans will be unable to set out for new missions and those already in space will be stranded and will be unable to be resupplied. Currently, there are 70,000 objects of about 2 centimeters in size orbiting the Earth 850 to 1,000 kilometers about Earth's surface. Out of the 200 to 600 orbital reentries each year, approximately 20% may be large enough to have survived reentry. Although most of these small pieces usually drop into the ocean, sometimes they don't. For example, parts of a Russian X-Spy satellite fell through the atmosphere and came very close to a Latin American Airbus carrying 270 passengers in 2006. With 2,666 satellites orbiting Earth right now, many spacecraft are bound to change course due to space debris. In this case, the Space Shuttle Atlantis became the second crew of 1991 to avoid incoming debris from a rocket launched in 1976, 15 years prior. With only 7 seconds of burning its engines, the shuttle crew was able to steer clear to safety, but many other satellites may be unable to avoid it in other spacecraft as well. NASA reports that one piece of debris has fallen back to Earth's surface every day for the past 50 years. Because Earth is made up of 70% water, the chances of being injured by debris are slim but not impossible. For example, Lottie Williams lived to tell the tale after being hit on the shoulder by a piece of a fuel tank from a Delta II rocket in 1997. This shows that space debris can affect humanity outside of more abstract and separated damages to satellites, making it a bigger threat than ever before.
So now we'll go over the solutions to space debris. So, like David explained earlier, why do we need to take debris out? It's because tiny objects can have an extreme amount of force if they have a high enough velocity. And if you really want to understand why, you need to first understand the physics equation F equals ma. So say a bolt, such as the one pictured right there, has a mass of around 50 grams, but it has a velocity of 28,000 kilometers an hour. If you multiply that out convert it, then it will have over 6,000 pounds of force. That tiny bolt will have over 6,000 pounds of force. And in order to make sure no one gets killed or no satellites get damaged, we need to take these out. So Japan's Aerospace Exploration Agency is working with Nitto Saimoco, who makes high-quality fishing nets. And the plan is to make a giant magnetic net that will span a few kilometers. So the fishing net will be made of metal, will be magnetic, and is going to be attached to a satellite. And as the satellite orbits the Earth, the net's going to catch space debris along the way. And as the net gets full, then the satellite and the net, along with the debris inside of the net, is going to burn up as they re-enter the atmosphere. And so some companies have wanted to create a machine that will shoot a laser into space in order to burn large pieces of space debris. And while this may seem like it's only science fiction, there's actually pretty good reasons as to why they want to do it. So some reasons why they want to pursue this idea is that it'll save money, since you don't need to use rockets and other resources in order to send another satellite into space to catch debris. There's also some desires to have some kind of device that'll tow old satellites to the International Space Station, where they'll be restored and repurposed for other tasks. And this will reduce the amount of things you're actually sending into orbit. But you may also save a lot of money, because instead of rebuilding an entire new satellite, all you have to do is restore a portion of an old satellite. There's also been suggestions of an international agreement to pay a set amount in order to send a satellite into space. So this will make companies more conscious on how many satellites they decide into orbit, and it'll also increase the value of the satellite industry by billions or trillions of dollars in the next decade. And to apply this into real life, there's actually one company right now that's making something to remove space debris. So their device is called Clitter Space One, and it's planned to launch into orbit by 2025. So this device is going to use robotic arms to collect and store pieces of debris. Then once the device is done collecting debris, it'll fly back into Earth's atmosphere, where the debris will be burned up. And hopefully, if the initial test goes well, they'll be able to launch many more. Thank you.
Oh, Victory, you're muted, by the way.
Go ahead. I'm so sorry. Thank you, Clarissa. So
No
I was
problem.
saying, can we please give like a virtual round of applause to David C, David B, and Presley. If you have like clapping emojis, you can put them in the comment section. That would be really nice, because they've been so awesome. I mean, we've learned so many new things today. There's so many things I didn't know until after joining this session. So it's been so cool. Thank you guys so much. And just in case we didn't know, Boeing is pretty much the largest aerospace company. I think I got that right. Yeah. So they create aircrafts. They do so much. I mean, probably every airplane, or the majority of any, if you've ever been in an airplane, if you were in that airplane, Boeing was probably the one that created it. So thank you guys for joining us. That's been awesome. Just quick reminders. for 2 weeks, we're going on a break. And on the 1st of August, we'll be back, just like Clarissa said at the start, with new classes, new sessions that will be more FLO centered and EB3 robotics centered. So it will get more difficult, but I'm sure we can do it. It's going to be fun. It's going to be awesome to just learn more so you guys can have fun and chill, but don't stop honing your skills. Like Clarissa said as well, there is a computer aided design video already, even though there won't be a computer aided design class. And yeah, so just be excited for when we resume. This isn't the end of Coderina. I think we can all say that Coderina has been so awesome because these classes have been free and they've been so informative and educational. Thank you so much, Coderina, on behalf of everybody. Yeah, guys. So that brings us to the end of how many weeks? I think 7 weeks now, because this was a bonus week. So about 7 weeks of learning, which has been really cool. So thank you guys so much and have an awesome day. Bye.